Hello everyone, welcome back. In this video, we are going to see the MATLAB simulation of phase-shifted full bridge converter. The difference between phase-shifted converter and dual-active bridge converter is that in dual-active bridge converter, we have bidirectional flow of power and in which we have two active bridges. But in phase-shifted full bridge converter, only one converter is an active bridge and the another converter is the uncontrolled bridge. So let us construct the converter with the following, with the parameters given by this table. So we are going to take the input voltage to be 100. We are going to use the transformer whose kVA rating is 200 and the switching frequency is 30 kilohertz. L is taken as 1 microhenry and C is taken as 606 microfarad and the load resistance is taken as 5 ohms. The kp value of the PI controller is 500 and the Ka value is taken as 50. Now let us construct the converter in the MATLAB. Open MATLAB and open Simulink library browser and let us take the new model. So to construct the circuit, we need 4 MOSFET switch, control R, the MOSFET switches are connected in the bridge fashion to form the input bridge. Then we need an input DC voltage source. So the DC voltage source is taken as 100 volt, which is connected to the input of the MOSFET bridge. Then we need a linear transformer. We need 2 winding transformer. So let us untick this 3 winding. Then choose the units as SI. And let us take the VA rating of the transformer to be 200. And the frequency of the transformer is taken as the switching frequency, which is given as 30 kilohertz. Then the winding 1 voltage is taken as the input DC voltage, which is 100. And let us take the value of R1 and L1 to be 0 and 0. So we are going to consider the ideal case. Then let us take the output voltage of the transformer to be 15. And we are going to take the winding resistance and inductance to be 0 and 0. Let us keep the magnetizing resistance and inductance in the default values. Now we will be connecting the primary of the transformer to the output of the input bridge. And in the secondary side, we need a diode bridge. So we need 4 diodes. The secondary of the transformer is connected to the diode bridge. Then we need to have a inductance. So type RLC series branch. Let us take the inductance value as 1 microhenry. And the capacitance value is taken as 660 microfarad, 606 microfarad. And the output resistance is taken as 5 ohms. So connect a voltage measurement block to measure the output voltage. So let us use go to tab and let us name this as V0. So we will see the waveform of the V0 using scope. And let us also see the display. Now we need to give PWM signals to the MOSFET switches with the help of RAM. So let us name this as PWM1. Then we need to use 4 PWMs. Let this be PWM2. We need to compare the output of the converter with the reference. So let us take the reference voltage to be 10 volt initially. And this need to be given to a sum block. Change the sign of the sum block as plus minus. Then we need to use a from tag and the signal to be V0. So the output of the sum block is given to a PI controller. So choose PID and change this to PI. Then let us take KP value as 500 and the KI value as 50. And let us take the saturation limit to be 180, upper limit as 180 and lower limit as 0. Now output of this PA controller is given to a MATLAB function block. We need to write coding in this MATLAB function block. The coding which we are going to write is this one. This code I have already typed in the Word file. So I'm just copying it into the MATLAB function block. I will give you this coding in the description. You can copy and paste while doing your simulation. So the input of the MATLAB function, there are 3 inputs to the MATLAB function. One is the phase, which should be connected to the output of the PA block. And the one is the frequency, for which we need to use a constant block to feed the frequency of the system, which is 30 kilohertz. Then this one, we have to use the clock, which should be given to the T. Now we have two PWM signals. So one PWM will be given directly to PWM1. That is, so we need to use a from block, and we have to name this as PWM1. Sorry, we need to use a go-to block and name this as PWM1. And this is given directly to one PWM of the function. But the PWM2 should be given through a NOT gate. So this should be renamed as PWM2. Similarly, for PWM3, we can directly give the another PWM of the function, and for another PWM, we need to use a NOT to feed the PWM4. So we have given all the 4 PWM signals. Now we need to have a power GUA block. And let us change the simulation type to be discrete. And let us take the sample time to be 1e power minus 8. And we will also change the simulation time to 1. And now the circuit is ready to run. So we can find that the output voltage is maintained constant at around 10 volts. Now we can change the output reference value to 12. We change the reference value, the output voltage, it is changing towards the reference value of 12 volts. Again, we can change this to 9 and check whether we can change the reference value to 8 and check whether the output is following. So we can find that the output voltage is now following the set value of reference, which is 8 volts. So we have stopped the simulation, and we can check the waveform of the output voltage. So we can see that initially we have kept the reference voltage at 10 volt. So we have got the output voltage following the reference voltage. And next we have changed the reference value to 12. And then we have changed the reference value to 8. So the output voltage, it is able to follow the reference set value. So we have got the reference value, the output voltage value, which is following the reference value. Thank you.